Well, welcome. Then let's look at example C. On example C, would you turn and talk to your neighbor? What's so funky or strange about this problem?
7.5. Yes.
5, 4, 3, 2, 1. I need to start moving on. Okay, let me call on Gary really fast. What do you see that's different here?
There's a decimal and you're multiplying into.
Winner, winner, chicken dinner. There's one thing I need to ask you. Gary, from example A and B, where was our variable usually on? On the left side. Okay. So, again, if I were to draw that diagram of how the equal sign is like a fulcrum, and we have a left and right side of our seesaw, on the left side, we have 7.5, 7.5. On the right side, we have 3 times some number z, 3z. If a seesaw indicates that both the left and right are equal, then what I'm going to do is I'm going to flip-flop. Whatever's on the right side will now move to the left, and this will then, of course, go to the opposite side. Because it's like switching weights. They're both equal weights, so let's just switch on which side they're on. So what I'm suggesting is rewrite the problem as follows. 3z equals 7 5/10. I hope that makes sense to you after looking at our diagram. If you are in the group where you like your variables on the left, then by all means, feel free to switch it up. However, this does not affect your answer. So if you choose not to rewrite the problem, you're totally fine as well. I mean, you're fine looking already, but what I'm saying is that won't affect your answer. You know what I'm saying? G. Okay, let's keep this going. The inverse operation of multiplying. Right here is multiplying, folks. Even though there is no multiplying sign, when you have a coefficient next to a variable, that means multiplying. So the opposite of multiplying is division. So here I go. Excuse this. I don't know. Sorry about the interruption, guys. Okay, let us divide by 3 on the left. Let us divide by 3 on the right. This division of 3 is the inverse of multiplying. Are we cool with that?
Yeah.
I'm going to record that. The inverse operation is dividing by 3. Okay, I'm going to highlight here the 3 divided by 3 because that makes 1. 1 is now the new coefficient. It's sitting in front of z. So over here on my Cornell note, 3 divided by 3 is equal to 1. That's like fractional talk. If you have 3 out of 3, that means you have 1 whole group. True?
True. Yes.
There's that. Okay. And then over here, on the other side of the equal sign, is a division problem. 3 goes on the out, 7.5 on the in. I do this because, well, I have an improper fraction. Let me highlight that for you. Aquí is an improper fraction. And improper fractions can be changed using division. Where the top number goes in and the bottom number, the new denominator, goes on the out. Alrighty? I'm going to go ahead and do this division problem. First of all, I'm going to evaluate 1 times z. 1 times z is simply z. And then 3 goes, well. Hold on, before I start rolling. When you divide decimals, you only need to move decimals if the outside denominator or outside divisor has a decimal in it. It does not. It's perfectly fine. So place your decimal point straight up. 3 times 2 is close to 7. 7 minus 6 is 1. You're going to bring down that 5 to make 15. And then 3 times 5 is 15. I have a remainder of 0. Had there not been a remainder, let's say there was, 15 minus 14, there's a 1, you would have to drop the 0 and drop it like hot. Alright, z is 2.5. And you know, I always say you can check your work, so why don't we check our work? If z is 2.5, let's go back to our original problem, where there's a variable. We think z is 2.5, so I'll substitute the z there. This is a decimal point. Excuse my handwriting. Then I'm going to go ahead and multiply that. 2.5 times 3. And I have to count my decimal places and move it over one time. So this side on the left is 7.5, which is the same as on the right. So I have checked my work. 2.5 is the real answer.